Two, one, we are live. All right. Well, welcome everybody to Omaha Data Science Academy, to the final class, class 8 of the data manipulation and management class as part of that initial BI data analyst track. And this class is advanced database functions. So this is where we are going to learn some of the things that are advanced functions that are available within a relational database past just the regular SQL query language. So things like temporary tables that are non-permanent tables, which you can hold data in, which is great for taking intermediary steps with your data. And then other functions like stored procedures that you can call on demand. So more of like a procedural language like you would see in Python, very linear and multiple step by step. Data, you can create your own user-defined functions, which is really cool. So we learned about aggregate functions, so those things that you can summarize columns by. And you can also create scalar functions, so being able to define your own functions using this procedural language and then applying it to the SQL query language to be able to get the results that you want. And then database triggers. So database triggers are things that update tables based on events. So you can think of events like we did in that third class. So things like updating tables, inserting and deleting data from tables. If those events occur, they're the majority of relational databases has some type of trigger functionality where you can create your own triggers using a procedural language to be able to tell the database to do certain things before or after you do these activities. So these become really valuable to make sure you're keeping your data integrity within tables so you aren't inserting a bunch of false values that you're really shouldn't be inserting into the table. Kind of similar to constraints, but you can write these as some rules too. And other things just naturally when you're inserting data, perhaps it impacts a number of other records or other things. You can really guide the relational database using this language to kind of direct it what to do. Maybe it's updating values, different values when you insert a record. Maybe it's cleaning up null values. So if it's a null value, perhaps you fill it in with some other value based on, based on another key value or other way. But we'll see this coming up, and happy to teach this for the first time because they'll very much at least familiarize you with a different way of using these relational databases as opposed to just the query language to get things out of tables, or the data manipulation language or the data modeling languages to build tables, or to just do straight up inserts, updates, and deletes. Well, kind of like some advanced things you can do with the database, advanced functionalities. All right. So class 7, we covered this here right before we logged on to class, but in the last class is all about data within the organization. So terminology, management versus administration, data governance, data stewardship, those type of entities that exist to try to help make sure that data is of the highest quality and the integrity remains with data in organizations. Data dictionaries is kind of like your map around the different systems, the sources that data comes from, how they're transformed, how they're defined, where they live and located. So kind of like if you think of a data dictionary, it's like a data roadmap, like a to and from, like where does all your data start and where does it end and what happens in between and how it's defined, really can help the end user navigate data, especially in a large organization with tons of data. And then data warehouse and versus operational transactional data stores. I saw in general, at least in a traditional sense, how data usually flows within the organization from source systems to data store to data warehouse, all the way out to the end user. So data is often actually in movement. It's not just necessarily living in one database table or database. Maybe it's multiple databases. You're bringing it all together, transforming it at different points for different purposes. And then after all of that work, delivering the exact data or the data that the end users need. So hopefully it's just an overview of what you would see data within an organization, how you would see it. And maybe as much as anything, just an appreciation for all the steps in between that lead up to kind of that end product, how you deliver to the users. Lots of work and even different roles to help maintain all that data. All right, class 8 objectives. Now you have the power, I thought, of Neo and the Matrix with everything that we've learned in SQL. But the advanced functions are really in addition to kind of like the core SQL language that we learned, the SQL query language. So the SQL query language is really about being able to gather data from tables or creating those structures, the tables, those structures to hold data, and then being able to manipulate it and maintain it. So inserts, updates, deletes, and even joining tables together, doing subqueries, using functions and cleaning it and so forth. This is really the advanced SQL functions use the SQL procedural language as I was talking about. So it's a little bit different, but it provides its own kind of value in the sense that we'll see that you can do things a little more in multiple steps. So instead of trying to fit everything into a single query, we could create things like stored procedures where you could have things, data that kind of goes in multiple steps. From this, we will learn the procedural language, like I said, is a lot in that first slide in the introduction, a lot like Python in the sense is that you can declare variables. So not just static values, things that can change, and then use if-then logic. And then after we learn the basics of these differences and some of that linear declaring variables, procedural if-then logic, we'll take a look at the routines because we'll take this language and we'll start building on different SQL routines. So stored procedures, functions, and triggers. So when I said this varies greatly between database management systems, even like MySQL and Microsoft SQL Server or other servers. Basically, all these databases have some sort of ability to create stored procedures, functions, and triggers. It's really in this procedural language where there's quite a bit of difference as far as syntax and structure and so forth. We'll learn MySQL syntax. And I think it'll be good enough to at least get you started with understanding how you use these different SQL routines. And like we saw at the beginning of the course, all this information on the specifics of the language are online now, so you can watch videos or be able to look them up and see kind of what's the difference between these two database management systems, because even if they have some nuances and differences, there's also quite a bit of functional similarities. You just have to figure out what the transition between the two are. So he'll be kind of keeping it high level with examples today, but introducing you to it so that you're familiar with these. And if you see any other database management systems, it'll be just a matter of knowing these routines and then figuring it out how to do that within those own database management systems. All right, so temporary tables is where we're going to start. I like starting with this one because temporary tables can be used in any one of these SQL routines in one way or another. It can even be used to hold the results of a query. So temporary tables are a special type of table that allows you to store a temporary result set, which you can reuse several times in a single database session. I think there are a lot of advantages to it. We'll cover just some of the following properties here before I talk about that. But a temporary table is created by using a create temporary table statement in MySQL. So this will vary between how you define temporary tables between database management systems, but basically all the database management systems have temporary tables. They can be used as a table in any user query within the current session. So you can just use them exactly like tables. And MySQL will remove these when the session ends or the connection is terminated. So you could say, well, why would I want just my data to go away? And maybe it's just you're running some type of procedure or you're running a multi-step process that you don't really need the results to be stored off online because you can just go and run the script in the future and it'll reproduce those results. Think of MySQL, think of it as like something that can be used as intermediary steps within a longer script. So if you think about it, if you're storing permanent table, a lot of permanent tables are going to persist in the database. The number of tables are going to grow. It's going to get kind of messy. The database administrator is going to start to get grumpy with you and say, can we delete some of these tables? Are you really using it? So temporary tables are probably also used for temporary uses or one-time uses or some type of other procedural use. And we'll see this especially when we take a look at stored procedures here shortly. But over on this right side, I have a couple of examples. And this is the outline of how you would create it. So you would use the create temporary table clause or statement within SQL. You define the table name, columns, and table constraints. So really very similar to how you would create a regular table. It's just not as a fully persistent table over different sessions. This table will go away after you disconnect your session or you're basically done with whatever you're doing. One maybe even better feature I found is you can create a temporary table with an existing structure. So you can do something like this. It's almost like an insert into, but in MySQL, you could just select a query and it'll take the data types from that query and just build this table for you. So instead of having to like define all these different columns and the key constraints and everything, it'll just take this query and load it in a temporary table for you. So it's very much almost like a view in some ways too, but it's actually kind of like materialized data. So you have actually taken like this temporary table and put data in it to be able to use other places. Whereas a view, you don't really get that data until you run the code. And then the query the temp table, it's just the same in MySQL. As a regular table, so you just select star from your temporary table name. So in different languages, you might end up putting like a pound sign in front of this to these temp tables to denote that it's a temp table. In MySQL, if you use this create temporary table, the database system will automatically know that it's a temporary table, and then you can just use that anywhere. Any questions on temporary tables and the purpose of them? Say, we'll see this coming up shortly. I think that might help, but Just wanted to explain a couple of the uses. I actually use temporary tables very, very frequently, especially in multi-step processes, as we'll see coming up. And it can even be used as kind of like a subquery. So if you have some type of subquery, you could store the results in a table. First, think of a subquery in a where statement. So like you're bringing back a subquery that's the results of a whole table. Instead of doing that inside of the query, you could just load that subquery within a temp table and then use that temp table directly in that next query. So your first step would be building the temporary table. That's kind of like the subquery. Then your next step would be using the temporary table within the query. All right, and we'll see examples coming up here, like I've said. All right. But first, before we get into procedures, functions, and triggers, let's define a routine within a relational database. So these are program modules that execute on demand within a relational database management system. So these are things that the user can create and program using that procedural language that you can actually call a procedure, call a function. You kind of call a trigger, but you place a trigger. That's more placing it on the trigger, and then when an event happens, it happens. But these are kind of things that execute on demand, either based on the user calling them, like a function, or a trigger of like some type of database event. So when you thinking about procedures, these are routines that do not return values and can take input and output parameters. They're called explicitly. So when it says do not return values, it's not going to necessarily return a value in a sense unless you do that explicitly. It is more going to either return a result set to you or the results of a query, or it's going to do something like an update, delete, insert behind the scenes. So you trigger this procedure to be able to do some series of steps for it. That can be a number of things. All right, so user-defined functions. So these are just like the scalar or the aggregate functions we learn, but user-defined functions are ones that you can create yourself. So these actually return values. So if you think about those functions that you create, take like a date diff function. So if you're comparing two dates, the value of the function returns is the number of days between those two dates, or however you define that, number of days, number of months, number of years. So these functions will return values and take input parameters. So the difference between procedure, it's kind of like a thing that, runs step by step. The defined function is a function that you use in conjunction with the SQL query language that explicitly returns some type of value for you, like the date diff function, or maybe like a summary function over a whole column. And I have two examples of that coming up. And then the trigger is a routine that executes in response to a database event. Like I said, updates, deletes, inserts. You can do these before you insert something, or update or delete to make sure you don't do something that you don't want to do, or afterwards, kind of like to be able to update multiple things after that data has already been inserted. If you think about this visual down here, it's really the trigger performs actions, and it shows the operations that you do, and it triggers. The procedures and functions is really code you store, and then you call it. So when you're using the date diff function or a sum function, you're really calling like one of the internal functions within the database server, one of the pre-existing ones that a whole bunch of people already use. But these would be more like the functions that you create or ones that you customize for some certain purpose. We'll we'll see one here with on the project data where we're returning just we're labeling the console. So we're giving it actually a list of games, and based on that game, we're returning if it's an NES console or not. So it's a customized function to do just like exactly that purpose instead of one of the generalized ones. So really all of this, the advanced database functions they're really giving you like an extra level of functionality past what you can do with traditional SQL query language. As powerful as a SQL query language is, this is almost like being able to program the database management system to be able to, take the functionality to the next level. Right. Oh, standard versus procedural SQL. So now we're getting a little bit into the differences between the languages. And I kind of mentioned this already, is that the standard SQL, usually simply as SQL, is a type of programming language called a query language. It's used for communicating with the database. Kind of like what we said the first lecture. You're sending it like instructions to be able to do certain operations that the database already knows how to do. Stuff like select, group by, order by, where clause, so what tables to pull your information from, updates, deletes, create tables. Basically everything that's already canned, you're basically sending it instructions and communicating with the database. It's kind of like that language that you speak with the database to tell it what to do. So SQL statements are executed one at a time. This is also known as non-procedural. So it's if you think of a procedural language, Python can be used as a procedural language. So it can be ordered in a very step-by-step manner. You can create functions with parameters and variables, be able to return values and so forth. So these procedural SQL languages, they execute statements in a scripted procedural way, like Python does. The code will be processed as a block logically in a structured order. So the standard SQL, it also has a structure because you have to put the different clauses there. But this is more, the procedural language is more of a ability to kind of program and add functionality to the database in a procedural way, in a very logical and step-by-step manner, which is more like traditional programming languages. So if you notice, SQL is more of like, it's very useful as far as being able to query data or do whatever you want in a relational database. That's really about like communicating with the database, like much more like natural language. Like, I want these columns, I want it from these tables, bring these tables together by these key columns, limit it to where, and so forth. Whereas procedural language, like I said, is really expanding that functionality. It gives you tools to be able to do that. So I kind of see them as, it's all SQL in a way, but two different ways of trying to do what you want to do for two different purposes in the databases, in database management systems. All right. So MySQL, their procedural language is called persistent stored modules. So you'll see it in other languages. In Microsoft, it's called T-SQL or transactional SQL, just for that sense that it's much more transactional and procedural in nature. So different databases will name it different things, but some of the common things that they'll have specific is things like being able to declare constants, variables, and cursors. So your constant and your variables are like your X and Y. And your cursors are like just being able to traverse data. You did some of that in Python, being able to traverse data row by row and do operations on different rows. It handles program logic with conditions and loops. So here you have this program logic, very much if then. So, and then you have your logic within each one. So kind of like a case statement, but of course in Python it'd be like if then else statements, or you have case statements there too. But if then logic, and handle exceptions that occur during runtime. We will see one example of that before the end. So like very much more like Python than it is the kind of like the standard SQL query language. And then the syntax is over here. So for basically any routines you create, and this is specific to MySQL, you follow it at the beginning and end with these delimiters to tell it where the procedure stops and ends. You reuse that at the end. And then you have a create statement like you do with tables. You tell it to begin and end, you declare your variables, and then you have your logic in between. We're about to see a few examples of this. All right. And I think throughout this, I put some amount of comments in here. I guess not that one, but different references to be able to learn more about these things, like where you can see specifics about MySQL stored procedures. And then I have a number of notes in here about the syntax and the different things that are in there. All right. Go back to present. I'm actually going to give this a try. So stored procedures. So this is the first of the routines you can create. So the definition here is routines that do not return values and can take input or output parameters called explicitly. So you can create return data sets from this, or update or delete values, but it doesn't specifically return a value like a function does. So a little graph or diagram here. I'm going to go back to this view, actually, so I can see everyone. So the delimiters here, same as this very same structure here as we saw on the last page. But on this one, you do a create procedure, procedure name. So now think of this as like a function within Python that you would call. So you're defining a function or creating a procedure. You have a number of parameters for each function. And the in, out, and in, out, these are different variables, different types of variables that you can create with the stored procedure. So you can tell it, these are my input variables. These are my output variables. So you can actually kind of, if it's an output variable, you can call that variable in a way to be able to see what the value is. But the procedure itself doesn't explicitly return it. You have to be able to call it yourself. And we'll see an example of that too. And then in, out, so it's both an input and an output variable of the function. And then you give it variable name and the different data types it has to be. So with that, you do a begin, you declare your variables, add SQL code, and end. And then to call this procedure, you call it like a function. Although with these, you really don't. You could put these within SQL queries, but oftentimes you call them separately from SQL queries using the call, procedure name, and then your variable list. So kind of one of the big uses for this is either two of them I can think of. It's between applications and the database. So application, maybe it needs to be more dynamic than just a static query. So you can create a procedure with different parameters. The application can send it any number of parameters. Maybe it gives it date ranges, and then the procedure name, calling the procedure from that program, it will just return them specifically that data for that time range. And perhaps it needs to be dynamic, right? So the program would pass those parameters or those values to the database, the stored procedure in the database, and the database would get it exactly the right information. If we're thinking from an analytical perspective, oftentimes people create reports within stored procedures that have different variable parameters. So maybe there's a reporting portal. You create a stored procedure with a canned report in it, and then the user inside of that portal can enter date range, and then it call the stored procedure, bringing back exactly that information that they want for their report. So a little more dynamic in nature than your typical queries. Or you can just define a stored procedure to do a number of steps like deletes and updates, inserts into different tables and things like that. So it doesn't necessarily have to return any data or data set, but it usually contains a number of steps, and usually a number of steps inside of it, or some type of parameterized query like we were talking about. So let's go ahead and bring this to life. So here's an example of a stored procedure. So the example here is to create a stored procedure that gets all pre-ordered Nintendo games between the start rank and end rank positions. So this is going to be more of an example from an analytical perspective. So this example I created should be within the PowerPoint SQL code. But you have your delimiter, you create your procedure, created in the class project. I have my in variables and then my out variable game count. And then I define those data types as all integers. Because the rank that we're going to send it is going to be a number from 1 to whatever. The end rank is 1 to whenever. And then it's going to count the number of games in between. So the begin and end statement, I underline those because that's kind of like the framework for your logic. The first step I do is to drop the temporary table if it already exists for whatever reason in that session. And then I create a temporary table for selecting everything from the US pre-order chart where the console is equal to NS. So NS is Nintendo. So this is really what this query is doing is really going to get the ranks and see all of the games that have the console of the Nintendo Entertainment System in it. Right. So after I've dropped and created that temporary table, the step 2 is to return the results between the start and end rank. So eventually when I call this procedure, I'm going to ask it to do the ranks between 4 and 10. You could have it any number of ranks within there as long as those ranks are integers and they meet the data types of the parameters. You can see here's kind of like a parameterized query. So selecting everything from pre-order NES where position is between start rank and end rank. And then step 3 is this output variable. What I end up doing here is selecting the count of how many are in this result set. And I'm going to restore that value. And then I'm going to call it later to be able to select the game count later to see how many games were in the results. So go ahead and try to run that code. Give it a chance. I believe that you can create this within your schema you're likely going to have to put class project in front of these, like the view USA pre-order. So let's take a look at that. Let's go ahead and do this and try to create our first stored procedure. I'm going to take this out of there too. So this should be the first example for lecture 8. So I'm actually going to go ahead now and try to create this inside of my own schema. Creating these tables this way, it may give you an error. Ronnie and Maura and Michael, let me know if it does. You may have to create the temporary tables in your own schema also.
I put my schema in and it worked.
Okay. And you keep this one because you're going to use this view from the class project, from class project pre-order NS, where that's positioned between start and end, and then set that. Oops. Class project, and I'll save these and make sure I update these too. But if we run this, oh, mine just froze while I did it. But in a second it should run, and it's like a create table statement, although it ran everything above it, didn't it? All right, so I'm going to put this in its own window and run it. Unknown database. Oop, did I forget an N here somewhere? J. Bergman. That should work.
Yeah, it worked for me. I just changed the two class project schemas to my own, and it ran. Now, I did notice that I don't have the view, the VW USA pre-orders view yet.
Okay. Yeah, you could use that from the class project. You should be able to read that one. Unknown database, J. Bergman. It's right there. Create procedure. Oh, because I spelled it wrong. I don't know how to spell my last name. It looks right just staring at it. You're like, what is missing from this thing?
I think it was the keyboard.
Okay, so pre-order rank. So if it runs successfully, you will see a stored procedure called pre-order rank. I'm actually going to drop this because that might be an older version of it. And then run it again. And then if you hit refresh, you're going to see that you have a stored procedure here now with these parameters. So it actually shows you the parameters if you click on it. So your start rank is an in variable, your end rank is an in variable, your game count is an out variable. So now we can take the other piece of code and call this. We can call this as a function. So what I'm doing here is that I'm actually creating another variable, still using that procedural language. So I do a set to declare a variable. You do a set, and then I have an @ sign. Game count is equal to 0. So I just set it equal to 0, and then I'm calling pre-order rank with the start rank and the end rank, and then I'm passing this integer variable so it can store this out result. And then I do something clever here. So to get the value of that game count, I actually use a select statement. So I select that variable. So if we just run this piece, it gives me an error. Oh, here, let's do change that to J Bergman. 10, I think that should work. Class project pre-order NES does not exist. Why did I do that? Why did I have that in the from statement? Everybody was able to run that call procedure? Or do you get the same error message?
I'm trying the call procedure right now.
Okay. 1 second. From pre-order. I had something different in there earlier. Because that's not a table. So class project. Oh, that's right, because the temporary table is called pre-order NES. So since I put it in my schema, I have to do J Bergman pre-order NES. So anytime I want to change the stored procedure like a view, I need to drop the stored procedure. You can write a command for it or just do it visually. And then I'm going to rerun this. I don't know when that recreated a whole lot. Hold on. So I'm doing this in my own browser. PERG. Okay, so I created the stored procedure. And now that pre-order NES, that was a temporary table. So since I put a schema on there, I need to do the same here. Now this should work. There we go. And what's cool is now that you have this and it's working, you can do any number of ranges here. So I could do 10 to 100. And notice that the stored procedure is returning me a result set. And that this out variable, I'm calling that using a select. So let's go ahead and run this from 10 to 100. So now you see you have 13, 27, 34, 35, and 39, all with the NS console. And then if we run this game count, it should be 1, 2, 3, 4. It should come back with 6. Although it's coming back with the whole result set. Set game count. All right. Result 5. That's interesting that's at the moment it's coming, selecting this is coming back with the result set. It's coming back with the value earlier that was just the count here, but I'll take a look at that here after the lecture. We'll keep moving. But that's the idea, is that now you have this function that you can create parameterized either queries that you return or some set of statements. As you saw, there are multiple steps that I had here. So step 1, step 2, and step 3. Instead of just writing a single query or a series of queries to be able to do it. And then I was able to return a parameterized query. And I'll take a look at this here too. That should return a value instead of a whole table. And we'll do that here at the end of class. One of the things we do. Everybody good with the stored procedure? They were able to at least run this call and be able to get back different results. Worked for everyone?
I'm getting my table created. It failed when I ran it because it was missing a table.
Oh, getting a table, maybe or this view or
Right.
temporary table?
Yeah, from the view. But that's cool. I'll catch up on it.
All right. We'll keep breezing through. All right. Screen present. So next we're going to go with the user defined function. So unlike a stored procedure that runs multiple steps, a user defined function is going to return a value and can take input parameters, and then you can create it as either an aggregate or scalar function. So actually, you can actually do multiple steps with this. Very similar to a stored procedure, except now, like you said, you have a return data type. So you have some variable or you have some data type that's being returned, and you have this return variable statement. So it's like a function in Python, a return function, where you complete the function and you set some variable equal to this return value afterwards. In this case, we'll see where we apply it to a column in a database table to be able to either do this as an aggregate or scalar function. And then you have a number of steps here in between that you can do. And to call this function, you're almost always doing this from within a select statement because you're doing it on a series of values. So when you do a select statement on a column, it's going to return you that whole column and all of the values underneath from some table. So I put this graphic here. This is the advantages of user-defined functions in like an object-oriented programming language, but I think it also applies here to SQL and being able to create your own functions. So modularity, dividing big problems into small problems. So think of like perhaps you have to have some type of really complex query or multiple subtables or joins to be able to do something. Maybe you could create a function instead that returns exactly what you need. Simplicity, easy to read instructions. So if you have it well defined, you give it a good name, variables, and say what it is to do. It's easier than creating the query yourself once you have it defined. You can reuse it in multiple places. So if you have a function, instead of writing the same piece of code multiple times, you can use that function multiple places. It'll save you time from writing it over and over again. And efficiency. So if you design it right, you can probably make it even more efficient than joining multiple tables. Just if you know some ways to improve performance or just limiting the data you need or whatever. So there are a number of advantages to it. And then just that flexibility, being able to create it to be able to do whatever you want also. That defined function, maybe for a specific purpose or general purpose that you can use multiple places is valuable. All right, so here's an example of a scalar function. So we're going to create a function named getNESPublishedThat returns NES if the game can be played on the Nintendo console. And we're going to use the class project game, the game view from the class project to run the scalar function on it. So notice, remember with a scalar function, we talked about it goes row by row and provides a value or not. So like a datedef function, like a string function, if you have a string and you apply a string function, it goes row by row. And that's exactly what this function does. except it returns NES if the game can be played on the Nintendo Entertainment System console. So how I've done this is that start by using the delimiters, create the function named getNESPublishd. I want to send it a game title, so I want to know, given a certain game title in this column, is it an NES? Can it be played on the NES console or not? And I want it to return a text value, which is what these NES values are. All right, so the beginning and end, that's the logic in between. So I declare a variable game publisher to be text, and then I select all these values into game publisher, because game publisher is eventually the variable I want to return with either the null or the NES values. So you can think of this, so you select distinct publisher from class.project.game, and then I'm joining the publisher table on it. This one is that you'll have a different query actually in your PowerPoint examples, but it's pretty similar to this, where the publisher is NES. And then I'm taking all those results, and then I'm putting that in that variable to be able to return. So actually, let's just skip over to that because there's one part of this that I forgot to update that I have in the PowerPoint examples. All right. So here's the function example of the scalars. And I'm actually using I'm using game twice here. And I'll update these notes for everybody also. But the idea here is the same, is that I'm selecting the platform from this game table. I'm left joining it on the rank only where it's NES. I'm passing parameters, so game title and game rank. And then I'm returning what game console is selected for that game. So really, to see this in action, you can call this query below. So let's see, you'll probably want to change the create function to your own schema. Then I think everything else below it should work. So go ahead and run that part. I'm going to actually just run this in another window. All right, so if it creates successfully, you'll get 0 rows affected. And then you should see that. If I refresh, you see get NES console. I'm actually going to drop these other ones for now. So you've created that function. Now that you can use with queries. So now that we have this function get NES console that takes game title and game rank, you can now use this on the game table. And we're going to select game name and game rank from the table and pass them as parameters. So we see what happens here. So you apply that function. So in the query, we're returning game name, game rank. And based on both of those, we run the function, and then it returns null or NES. Is everybody able to run this one that was in the examples file? Say the one in PowerPoint, say I fixed this up and then I forgot to update the newest version in it. This is the one that you'll want. give everybody a minute to do that. Let me know if it makes sense or if you run into any trouble or not. So as you can see, it's really like almost its own programming language that is specific to MySQL or other database management systems that allow you to create this new functionality in the database. I call it the advanced functionality. I think I may have muted. Everybody's on mute, but it's all right.
You're good. Just making sure I can run it through.
Okay. We're just another example, and then it triggers away from graduation. Around scalar functions. So very much like, I like this, the languages that they give you, because sometimes they're good. It's things that this type of programming is good for with data. And then sometimes that just running SQL queries are more convenient. So it kind of gives you the power of both. Be able to do both. Use data in two different ways. Define functions in this way. Functions are stored procedures. I use stored procedures 9 out of 10 times. I do functions, but sometimes functions are useful. There is once that we created a function. It was a mathematical function that took inventory levels and then calculated standard deviations on them. And we did that with a aggregate function. Being able to apply mathematical functions or some other like return function that you need like this. But usually it can be done in some amount of number of queries or something. The values of functions are the value of creating a function is most useful if you're going to reuse that multiple times, some type of function multiple times. That you find to be really useful.
Mine ran fine.
Did it?
Mm-hmm.
Sweet. And some of this example is probably a little bit of a silly one because you could do a case statement and return NES or null, but it illustrates what you can do with scalar function, how you can apply it. I guess we've done scalar functions too on just some type of aggregate function that's hard to calculate in a single query, like ranks and stuff like that, or some type of moving calculation, like a moving average. and be a little bit easier to do with this type of language. I think now some of the, I could be wrong on this, but I think some of the newer versions of Microsoft SQL Server allow you to put Python code inside of stored procedures and scalar functions too. So you could actually use Python inside of SQL Server. I know you can do that. And then use it inside of stored procedures. So if like you're creating a model and you want to calculate it on some data, you can just put the Python code in there. Probably not quite that simple, but that's the idea. I haven't done it. I don't think you can do that with MySQL yet. Take a quick look. We want to do something like stored. Oh, this is just how to call MySQL stored procedures in Python. So that's not what I'm looking for. But let me know when everybody's good to go.
I'm good.
Ronnie's still working on it? Good to go? Okay. We'll take a break here shortly once we get through these next couple of slides. Let's see. View, present. There we go. All right, aggregate functions. So with user-defined functions, like I said, you can create scalar functions. Using the same language, you can create an aggregate function. So this example, we're going to create a function named getPublisherCount that returns the distinct number of game publishers by platform from that class project game view. So one of the minor differences that you're going to see here is that right here is in the select distinct, and this value that we're going to return, we're using a column function instead. So I'm doing a count of the distinct publishers for the platforms that we're using as parameters for the platform name. It feels like I'm missing something here too, so I'm going to take a look. No, that's right. I felt like I needed a group by statement here for some reason. So what this will do is you pass a platform name to it. You'll get the count of the publishers. It goes one by one. So you'll get the count, distinct count for each one of these platforms. And then you use the group by in your query that calls the function. It felt like I needed one there, but I don't. Because of how this works, going by each publisher one by one and doing that count. And then I do the group by in this clause. We'll go ahead and give that a run, changing this to, and I have created all of these in the class projects and functions in case you wanted to take a look or use them from the column from there. You should be able to create these in your own schema too. And I think if you change this, I think it should run. It should run all right. Oh, not jbergman.game though. It would be classproject.game here in this bottom one. So from the class project table, I want platform, and then I'm going to run this function, and you change that. So you can call a function by whatever schema is in and the function name, and by that parameter. So if I do that, I have to create this first. I don't know what. Let's run this in the other window. Looks like they must be missing a comma somewhere up above. All right, so it created that function within the jbergman schema, which I can now use on the class project.game. And it'll take a second to run that function on it. Then it returns the distinct number of publishers by each platform. Let me know if that works for everyone and when you're good to go.
I might have missed something when I was copying and pasting. For the create function of get publisher count, should there be a delimiter semicolon at the end? Because I think otherwise I get error code 1305.
Yes. I think if you run it once, then you don't have to run it a bunch of times, but yes, I think, yeah, you should have not on the ends, but they're on the delimiter. Basically just telling the delimiter where to start and where to end. I think if you run it once, it technically works other places, but it's better practice to have it. It should work if we do that there, start and end.
And I think and I don't know, I mean, it'd just be something better. There's a space between delimiter and semicolon.
Yes, you got it. Got it. Yeah, better form and practice to do it that way. How in other languages, haven't found another one where you use delimiters like that. Just a little MySQL trick.
Yeah, I agree when I saw that. Sorry, go ahead.
I think it just has to do with the syntax. They probably use end and some other keyword or purpose.
Right.
Just so in this one, you have to delimit it to tell it. Let's see, end of a beginning and end, or the end of the stored procedure, whatever routine you're creating.
Yeah, I agree. I hadn't seen that before either, so that was a surprise. But it's just how their engine works.
Yeah. Once everybody's good to go, we have database triggers.
26 rows.
Got 26 rows.
Yep.
Yeah, I think they're 26 game names in there. Or platforms.
Yeah. 26 rows and triggers to go.
Here.
I feel like I'm on the start of a song.
Mine is saying that the table doesn't exist.
And then do you get, oh, wait.
Hey,
Yeah, do you get
Manager.
code 1305 in your response?
I got 1304.
Oh,
Well,
okay.
because it says it already, so the function get publisher count already exists. So that means that already had ran. It's like the second piece of it. It's 1146 saying it doesn't exist.
All right.
Wow.
So, Maura, did you create this in your schema?
Yeah.
Okay. I'm going to rerun mine here.
So what I did when I got,
Make sure it works.
I changed the .game to be in my schema, and I had to take it out of my schema and use class_project in order to make it work right.
This one right here.
Yeah, anything .game. So anything .game, I left it as class_project.
Yeah, it looks like Maura, you created it in your schema, so you should be able to. Not for memory in the game. If you do here in the select mramsey, mramsey.b does not exist. I wonder if it's just something in your query, more somewhere here in between. That's causing that mramsey.b.
Yeah, I'm looking and I don't need, that's not even there.
Did you want to? I could let you share screen if you want.
Yeah. Figure it out.
Okay, let's add that to the stream. You said that one is not even there, so I see begin. Let's see, equals platform name. It looks pretty good. I'll have you do one thing. So inside of your schema, if you drop down functions, try to right click and drop function on the get publisher count. And
Hey,
then
Jeremy.
we're going to
Sorry.
rerun that code.
What if you did create function, and that'll show you what it looks like? Or, yeah, never mind.
I think I'm just going to drop it and rerun it. It might have
Cool.
created it and there's a typo or something.
Cool.
This one looked pretty good. That worked. I bet it was just a typo in the first one.
Okay. Yeah.
And then if you, then it's stuck there until you drop it or you alter it. Sometimes the easiest thing for me is just to drop it and recreate it.
Okay,
sure.
that's good to know.
Because there'll be like an older version you created, and it's like an older version of it. So you can always drop it and recreate it. Everyone good with this one? How to create user-defined scalar and aggregate functions? All right. All right, so one last topic here on the advanced databases and then advanced database functions. So triggers. So triggers are a little bit different than the stored procedures or the functions, which you call. These are invoked automatically when a change is made to data on associated tables. So it's event-driven. based on inserts, updates, or deletes. So if any one of these occur on a table, you can define some of the things that happen. So the syntax here.
You're not sharing your screen, just letting you
Oh,
know.
I know, I'm so used to just having it on. Dang. All right. Thanks for the heads up. Triggers, there we go. All right. Let's do presentation mode here. Pew. Format, tools, present. All right, so everything I said is still true. So this is more event driven than instead of calling these functions. So this happens. It's like a listener on a table. So anytime an insert, an update, or delete happens, or data changes, the database trigger looks for it, and it does some kind of user-defined event that you create in beginning and end statements. So the syntax for this is over here, very similar to what you see before, but very different now. So you can define these triggers to be before one of these happens or after one of these happens on an insert, update, or delete. So the before is more about like making sure that like an insert doesn't happen if it doesn't meet some type of rules. Like what, or maybe it's even something has to happen to the table before that happens, or other like foreign key relationships or something like that. Especially with updates or deletes, making sure before you update or delete, before that event occurs, something else happens, like some type of integrity check or something else that needs to happen in the database. After would be more of like updates. So after the insert, it's already inserted in the table. Maybe you're updating null values. Maybe you're doing some type of, action after you do the insert. Maybe you're updating some other tables based on the data that you inserted into this one table. Or in that same table, maybe you're updating another record or deleting another record. Maybe that record is taking a place of, you insert it afterwards and it's taking a place of an old legacy record, and you delete that old legacy record. So those are a number of ways that you could use these triggers, but there are a ton of them, really, and I can't even think of all of them off the top of my head, but useful, especially in those OLTP databases, the transactional databases that are constantly inserting or updating or deleting records, and having things happen as those transactions are entered into database tables. So primarily for those purposes, less so for analytical purposes. All right, so let's do an example here. I created my own example because these are can sometimes be challenging to create, and well, I have an existing example. They can be challenging to create and make sure they work. So this is an example of a before insert trigger. So before inserting an order into the table, check if the order date is equal to today. So this one was a good one. I pulled this. So saying it, I pulled this example from somewhere else, some of my previous experience or previous class notes. This is a good one because think of this as like an order management system. And if you're inserting orders into a table, you want to make sure that the date's correct on it before it's inserted into the table. So before you insert, make sure that this happens. So what we're doing here is we're creating this function. And we actually do something kind of neat here. So at the beginning, we talked about being able to handle errors. You can actually create your own error messages within SQL. like you can see here, you know how you have the different error codes like 1054? You can actually create your own trigger errors. Like the order date has to be today. Because so to be able to, like, calling the trigger is probably not the right word. It'd be more like invoking the trigger. We are inserting some value. We're inserting by values into the table, and we're inserting a value that is not today. So what happens is when you insert it, when you try to insert it, before that record officially gets inserted into the table, it checks this condition, it meets this condition, and it'll throw this error instead of inserting it into the table. So it can really be like an integrity checks, because kind of like constraints that we put on the table, either value constraints or like foreign and primary key constraints. This could actually conform, like it could, you know, meet all those constraints, but it could be a business rule, right? That we don't want these type of records to enter the system. Like it could meet all the other criteria and even be in first or second normal form or table inserted into a table that's in those forms. But this says if it hits this criteria, then don't put it in the table. It give me an error instead. And usually that's some type of alert out to whoever's managing the database or analyst who's doing it to say, take a look at the record, see what's going on with it, instead of it being inserted into the table and possibly wrecking some processes or whatever other havoc it could create. Probably likely wreck some other processes. So there's code for this. So one thing you'll need to do is there are 3 steps to this one. And I don't see, I created this earlier. So let me see if I'm just missing it somewhere. Hold on one second. I created this in 3 steps to create this table and then to create that trigger. But I don't see that code. So here's what I'm going to do. I'm going to have everybody do this in 2 steps or 3 steps. So first, hold on one second. So inside of classic models tables, I'm going to put this into, I'm going to put these 3 steps into Slack. Oh, it does a create function, or here, create table. If everybody creates this table first, then you'll be able to run those other 2 steps. Okay, and I need to reopen Slack. Cohort 10. All right. I just put that create table statement in there. Go ahead and do that first. I must have forgot to save that from earlier. Let me know when everybody created that table. Go ahead and create that in your own schema. So like J Bergman, got order. So that's slide 14. Okay. And the step 2, once you do that, is to create the trigger. So I'm going to pull that out of the PowerPoint slide. I'm pretty sure this is going to work. there's a little apostrophe there. jbergman.order. Okay, I need to create this table. Okay, so that appears in my schema. Okay, so I have this table order. Now you have to have the table to be able to create the trigger, because I'll show you. Once you create the trigger and that part is successful, and I'll paste this also into Slack. If you create it successfully, when you expand the order table, there will be this little label called triggers. Let's refresh. Oops. Let's have created that elsewhere. So do that inside of your own schema. All right, so creating that successfully in your own schema. There we go. It should show you a trigger called check date. So now these are like event-driven, almost like functions, but like event-driven routines that once something happens, it's built into the table, like a little listener. So when anything's inserted before or after, updated or deleted, these triggers are on to make sure those rules are still followed. And now if you try to insert those results, let me go ahead and put that as the third step here. Let's put tick marks around that one, since order is a reserved word. You see, since this date, the order date is not today, it gives you that trigger error. So that trigger ran before I inserted this record, and it said it met that rule that it was not equal to, that the order date was not equal to today. So then don't insert it and give me this error instead. But now if we put today's date on it, 2021, 10 or 11/10, this will work okay. 2021, 11/10, where it should work. New order date. I'll take a look at that too. But
hey, you're probably seeing this and looking at this too, but I'm getting error code 1644.
Yep.
Cool.
That's the one you should get. So I think that's like the user-defined error code. Like you do this like signal SQL state 4500.
Mm-hmm.
And I think this is like your user-defined error code.
Gotcha. Cool. Yeah, because the text looks right.
It's interesting, though, that this is today's date, but I have it just here in their own order. But that's today's date. Incorrect date value. I'm not able to insert that into the table. Let's run current date. just going to select current date. See what it says. Oh, because today, what? Today's not the 11th, right? I'm not crazy. Today's the 10th. The system thinks that it's the 11th, but I put the 10th in there and it says it's not equal to today. Heckle, I'm not crazy, right? Today's the 10th.
You are not crazy. Isn't there a command that we can run that gives us the current? Like we can just do select on current date, right? And that would
Yeah,
tell
that's
us.
what I did right below. And
Gotcha.
it gave me 11:11. I was gonna say you don't have to answer that if you don't want to. It must be a time zone thing or something.
Right, like if it's GMT or something.
Yeah, so it allowed me to insert that record because it does match the current system date. And if I select this now, not classic models.order, insert into jbergman.order. And now if I select this from the J. Bergman order table, that value, the record I just inserted by value, there we go. It didn't violate that rule, so it allowed me to insert the record. That's what I wanted to illustrate. So that's it for tonight's lecture. It took me a little longer than I thought. Does anybody have questions before we take a quick break? Work on wrapping up the class? It's valuable to know about these additional functions. You think that takes some practice, but we still know that the capabilities are past just the regular query language, which is the key. The ability to be able to kind of create your own customized procedures and functions, and integrity checks, triggers and integrity checks if needed. Everybody good for a break? Hey, like a 10-minute break to get grab something to eat, and we'll finish up the class project and answer any questions.
Sounds good.
Sounds good?
All right.
All right. Be back in 10, maybe about 7:45.
Cool.
And then I'll stay on as long as everybody needs, so you can go as late as we want tonight.
Okay, sounds nice. See you in a few.
See you in a few. Right. Thank you for attending this Omaha Data Science Academy class, Data Manipulation and Management. I appreciate your time and thank you for taking this journey with me. And hopefully you have gained very much practical relational database skills that you can use whatever your journey is, whether it's a data analyst or a data scientist or engineer, that it prepares you for the future. Thanks again, and wish you well. This is Jeremy Bergman signing off.